Hello everyone. That was quite some interesting keynote by Scott, as usual. But let's move on and discuss further topics down the road. So this session will be about DevOps and security and how can we keep track of security in the DevOps processes. My name is Mustafa Toroman. I work as a solution architect with Authority Partners. I've been Azure MVP for 5 years, been Microsoft certified trainers for many more years, very certified in Microsoft technologies, especially when it comes to cloud and Azure. So I've had opportunity to work with some major enterprise companies in the past, a lot of them Fortune 500 companies, and security comes very, very important to them. It should be important to everyone, basically, but when we are talking about big companies, they pay a little bit more attention than the rest. And as I'm a big proponent of DevOps in general, I had opportunity to convince them and try to work with them implementing DevOps processes and keeping security in mind. So we are going to discuss why we need this and how to get ourselves on track when it comes to security in DevOps. But let's start with DevOps in general. So DevOps is basically here. It's been here for quite a few years. It's not just some kind of industry trend, something that we might want to consider. DevOps is there. It's definitely helping us. It's proven to be efficient. Organizations doing implementing DevOps showed up to 20% improvement in time to market, in software quality, frequency of deployment, increased revenue, customer reach and retention. These are all topics that help us, where DevOps helps us. Like, it's helping us to improve in multiple areas, and it's helping us drive our business forward because we are able to deploy more frequently. By doing that, we are automatically getting faster to market, and it's keeping us with high software quality in the same time, and it helps us increase revenue and customer reach. But what does it include? So general DevOps process, and we're gonna keep a bit focused on Azure DevOps and Azure in general here, consists of a couple of things. So basically what we need as a first step is code repository. It's a place where developers are gonna place their code, where they're gonna push the commits. After the code is in repository, we need to set up build and deploy strategy. And once that's deployed, we need to test. We can also use beta testing in the cloud. And once the code is out there, it's tested, it's deployed, we need to keep track of it. We need to monitor and do analytics on what is going on. Based on that, we are creating new plans. We are creating new ideas what we should do. Is everything running smoothly? Are people using the new options, and so on and so on? So there are many metrics that we need to keep in mind, and then based on that, we are creating new plan. We are starting to vote on code. Developers are going to push code to the repository, and cycle starts all over again. So basically, this process is: we plan, we decide what we want to do, we code it, we build it, test it, release it to different environments. Once it's deployed, once it's out there, we need to do operation monitoring, analyzing what's going on there, and then plan again. Now, where does it fit? Where does security fit in all of this? I often heard terms like DevSecOps or SecDevOps, and people discussing, is it the first or the second, and what is more important in this? Do we just fit security in DevOps, or security comes before DevOps, and so on? There are many arguments. In my personal opinion, it's none of those. Basically, DevOps is it. DevOps is the process, is the culture that we need to go for, but security should be integral part of it. security should be very important of this process and should be considered at all times. So how? We need to have clear and concise communication. We need to apply infrastructure as a code and security as a code. We need to do mandatory trainings, and we need to do security integration inside the DevOps cycle. What does this mean? Like for the communication, and this is like first challenge in DevOps in general. This is where the idea of DevOps came from, where we had development and operations not talking to each other, and basically DevOps was there to bring them together to work on a common goal. When we include security in this process, the things get a little bit more complicated, but the principle is the same. People concerned with the security, and if we have dedicated security personnel in the team, should be included in all discussions, in all the processes, in all the planning, and this will help bring them together with the rest of the team. Same way the DevOps is introducing communication between development and operations, security comes into the same process, and with this increased communication we are trying to get better. But let's look at some numbers and where the challenges come from. So let's say that we have 100 developers. Statistics say that in average company, on 100 developers, we're gonna have 10 or less people in operations. This is like questionable if it's enough or not, but let's say for the time being that it is. 10 people in operations can handle the work of 100 developers, and they can work together on communication and building something good. But when it comes to the security, on these 110 people that we have, statistics again show that we have one security person involved. So 10 people on 10 operations on 100 developers, it might work. But we have one security officer, one security personnel on 110 people. This is like a big bottleneck, and security comes very questionable. Was it even reviewed? What was done? Because one person cannot oversee or cannot help 110 people at the same time. It's just not possible. If we spent a minute a day talking to everyone, it would be kind of insane to catch up and do anything else. So this is the first problem, and when we address this problem, communication also points that there is a big issue. Basically, security becomes bottleneck and cannot talk to everyone and resolve everyone's concerns and issues in the same time. So we, as a first step, we need to increase number of security personnel in order to increase and make a better communication inside our team. One of the most important things in this communication and process is that we need to do mandatory trainings. Basically, awareness begins at day zero. We need to be aware of current security risks, current security trends, what is going on in the cybersecurity at the moment, and so on. We need to do cross-discipline training for everyone on the team. It doesn't really matter if they are dedicated to development, operations, or security. Everyone needs to be aware of the common issues, and we cannot know everything. Like if we are trying to teach everyone on the team to have insanely good cybersecurity skills, it would be impossible, because people have different tasks, they have different obligations. If my role is to do operations, to monitor and maintain infrastructure, I cannot know everything about security. I need to know the basics. Same goes with the developers. When they are writing code, they need to be aware of the most common issues and what to pay attention at. But in general, that's why we have dedicated cybersecurity people that knows things a bit deeper, but still everyone needs to be aware of the basic things, and everyone needs to be aware of best practices and how to start with security. When it comes to communication, there are a couple of things that we need to address. Like big nodes are Excel lists and Word documents where we can have malicious attachments moving around through mail or different channels, no one knowing what is the latest version of the file, and so on, so on, so on. What we actually want to use, we want to use boards, we want to use common dashboards that people can relate to, that have a single data source in the background and can visualize where are we at the moment. We also want to consider Git and versioning to know the history of the changes, who made the change, why the change was made, and so on. So basically, we want to avoid communication through old-fashioned channels, and we want to push it forward with the tools that can help us drive this forward, and keep in mind that everyone is on board and have the latest information related to our project. We need to also pay attention to security as a code. There are a couple of things, like when people say security as a code, they usually think about infrastructure as a code and things. That is good, right? We want to pay attention to it, but it doesn't start there. It all starts with the application source code. That is code as well, and we need to keep it secure and good as well too. It's not only about infrastructure as a code. With cloud technologies, infrastructure as a code comes high in demand as well. It's really cool and convenient to consider security as a code in that part, and it helps us a lot. But we also need to address server configuration, like configuration as a code too, in this option, where we have multiple tools like Chef, Puppet, desired state configuration, and so on, that can help us get there, because as I said, it starts with the code, with our source code for the application. We need to keep it secure, clean, as much as possible. Then we have the infrastructure where everything is deployed. With infrastructure as a code, we don't really care about infrastructure anymore. We can deploy it in a matter of seconds. But then it comes a configuration as a code, where we need to set up proper environment for our infrastructure. Proper settings, proper environmental variables, and so on. So this configuration as a code is also very important in the terms that we want to maintain environment clean. Why? Basically, let's say that I have an application in production. Environment already exists. I will run infrastructure as a code just in case, to verify that everything is in place and running. And if it exists, the code will get deployed. But what if someone goes and just changes something randomly in one of the environments? Like if we have a pipeline where we have multiple environments like dev, QA, UAT, staging, production, and someone is working on something, changed something in dev, it started working, everything is nice, everything is cool. I run the pipeline for the next environment and it breaks off in staging. In staging doesn't work because the environments are not the same anymore. The configuration in one of the environments changed, and we have an issue. Now, the configuration as a code is there to maintain the environments same every time. So basically, if someone just goes and changes something to make it work, it will not work in the other environments because the change is not applied. We want to use configurations of the code to apply all changes to all environments to have it in a proper state. Same thing goes to if one of my colleagues had an issue, he was troubleshooting something, he wanted to temporarily disable firewall on the server and just forgets to turn it on later. He resolved the issue and everything was fine, but the firewall stayed off. That's a security issue. With configurations as a code during the deployment, we'll make sure that the settings and the configurations are correct, and it will set firewall back on as it should be. Additional thing that we need to keep in mind is definitely secrets management. With modern IT, multiple incidents where people push something to public repositories and stuff that shouldn't be published. They pushed some database connection strings. They pushed some sensitive information. We want to handle secret management separately. We want to keep track of the sensitive information and how we manage them. Basically, we need to plan how to handle all the sensitive information. They should never be inside the source code. They should reference to some other location. For example, we can, perfect example in if we are discussing Azure is Azure Key Vault, where we can have sensitive information placed and use as needed without exposing them openly in any of the files. Now, another interesting thing that we need to consider with secret management is that we can, during our application lifecycle, do secret rotation. So basically, we can switch out the deployment credentials and connection strings and what is used every time we deploy. So even if someone accidentally somehow gains access to in the environment, that can be overwritten next time, so that access is temporarily. We want to stop that access if possible in any case, but if it happens somehow, we have an option to secret rotation to just overwrite it next time, and basically avoid the situation where we have bad person with the access. There are multiple things with the infrastructure as a code that we can use. In Azure, it's really good to use RM templates. They are really convenient. They can deploy really complex environments, and they can be helpful in many ways. Now, in this slide specific, you can see that during the deployment of virtual machine, we might want to use, we need to provide admin username and admin password. Now, having those in code is definitely a bad thing. So again, we want to do some secret management and maybe add key vault reference in there other than the value that could be readable to basically anyone. There are multiple things why we want to do that. As I said, it can be accidentally pushed to repository that is publicly available or something, or in any case, not everyone that has access to repository are required to have access to this infrastructure that we are deploying. So maybe we want to keep it a secret with the limited number of people actually having access. Also, once it's deployed, we can use desired state configuration to set up roles, to set up all the information that are needed, configuration settings for our environment that needs to be as it needs to be configured to actually run our application. Now, I already mentioned, like when it comes to security, it should be integrated in the DevOps process. Basically, in this complete process, we already discussed the right picture where we have a usual DevOps process. When it comes to security, we have similar things. Security needs to be included in the planning. It's some initial idea and some initial baseline should be created. Then we need to verify what was done. We need to check packages. We need to do a release. We need to verify configuration, and we need to monitor security as well. So how does it work? So when it comes to planning, basically what we want to do is we want to integrate security in the sprint planning and reviews. We want people that are focused on security to be included in every discussion, and we want them to be part of the team. When dev and ops are discussing certain topics, we need to include security people so they can give their opinion on what's going on and provide their own suggestions on how we can do things better and how can we keep it secure at all times. Also, we need to consider security stories early. We need to define what needs to be done for each of our user stories, of our tasks in security concerns. We need to verify certain security things when we are doing even basic things, especially when it comes to more complex things like authentication, authorization, and so on. But every data exchange should be verified, should be considered from the security perspective as well. When it comes to coding, I already mentioned training. We need to train people. We need to push them to understand at least the basic level of cybersecurity and what needs to be done in that regard. We also need to set up test-driven development. It's really a key part of DevOps process and security integrated in that. Excuse me. Test-driven development is definitely a drive forward where we want to automate all the possible testings and verify that everything is on par, that everything has a correct baseline, and that it's running as expected. We also want to use correct tools. We want to define what kind of tools we want to use, that everyone on the team are using the same tools, because this was one of the big issues before the DevOps process in general, where people were across the board using different processes, different tools. We want to use correct tools, and everyone having understanding of the tools they're using. And we also want to set up a structure for the pull request. We want to set up branching strategy, how the code flows from the commit to release branch or master branch, or depending on the strategy you're using. But we want to define a hierarchy, how code from the commit is moved across the branches. We need to include pull request reviews. We need to add validations, code reviews, and different things. When it comes to build, we need to consider a few things that we can do during the build process. So continuous integration is integral part of the DevOps, and during the build process there are a couple of things that we want to see what is happening. We want to do static code analysis. We definitely want to do dynamic code analysis. We want to do dependency checks and package management. What does it mean? Like, for the static code analysis, there are some really cool tools that we can just include in our pipelines, and they will perform these kind of analysis. People are often mixing up static code analysis and dynamic code analysis, thinking they are one of the same. The difference is, with the static code analysis, code is analyzed in the state of running, like a plain text that we have, like our project is analyzed as a code, and it's detecting different dependencies and is it clean, and trying to see if there are any vulnerabilities in there. Dynamic code analysis do similar thing, but the difference is it's verifying code in the running state. So basically it analyzes application once it's running, once it's compiled and built. It's running the analysis and checking what's going on. How is there a possibility that someone can fool our code, bypass something? Is there known vulnerabilities in there, and so on. When it comes to dependencies check, our code, especially when we are discussing microservice architecture, rarely depends only on itself. There are always different dependencies. Like, we might depend on the database, I don't know, SignalR, Redis, or whatever. We can depend on third-party applications. We can depend on different APIs. So during the build, we need to verify the dependencies as well and see if everything is as it should be. And finally, in development, we use different packages. We import different libraries that can help us code faster. With package management, we need to verify that everything in those libraries, in those packages that we're using, is secure, up to date, that there are no known vulnerabilities for those packages and dependencies, and that we basically are using the latest version that mitigated some of the previous issues and so on. Okay, during the test phase, we need to develop security test cases. These should be included in the sprint planning. These should be defined along with the user stories. We need to define each of our tasks with security test cases, and we should execute them before they are being released. We also want to consider doing fuzzing. It's kind of a test that it's often mistaken for the load testing, because load testing is just like throwing the request at your application, seeing what will happen. Fuzzing is basically doing a random is throwing different requests at your application, but it's not doing it from the perspective of just throwing as many requests as possible, but trying to throw different types of requests, different values to try to provoke unexpected response, basically trying to throw you off, test you for example for SQL injection or the cross-site scripting and so on, basically seeing if just some random value, unexpected value in your application will break something off and allow bad actors to gain sensitive information. Load testing is basically seeing how your application is gonna perform in under big load, but in the terms of security, load testing is seeing if when application is under load, what's gonna happen. Are there memory leaks appearing? Is authentication breaking off and allowing unauthorized people to access and so on? So basically, it's still load testing, seeing how application performs under stress, but considering things from security perspective and seeing if something unexpected security related happens. When it comes to specific security testing, there are a lot of confusion about terms and what is used. For example, we have static application security testing, also known as white box testing, where we have access to the code and try to recognize vulnerabilities and break application off in security sense, try to access something that we shouldn't be able to, and so on. When it comes to dynamic application security testing, also known as a black box testing, we don't have access to the source code, but we are just like, we have a black box that we are trying to break in, trying to find a way around the security measures and trying to see if something broke off in there or we can bypass something. Both of those are kind of old technologies, and recently we have interactive application security testing added to the mix. That's basically combining those techniques and trying to adapt to more modern way of application writing. So basically, interactive application security testing is combining those methods and bringing it to a new level, adding new modern techniques to the process. So if we are developing modern application, especially in the cloud, then we should think about this approach. Okay, so once the application is tested, then it's release and deploy time. Now, during this process, from the security perspective, we want to do post-deployment security scans. We want to see if there's something off, something out of the ordinary, something that shouldn't be there. We also want to do a post-deployment checkout, see that all the necessary permissions are there, or again, something not, there isn't anything out of the ordinary, nothing broke off, application works as expected from security perspective. When it comes to application that is finally there, it's running, it's released to production, we want to do multiple things in order to operate and monitor the application. We want to monitor logs. We want to rescan vulnerabilities. We want to do this from time to time, just to keep in mind that things change in IT overnight. Basically, we want to do rescanning because of the zero-day attacks and so on. We want to track dependencies, see if the dependencies are running expected, and security is good in that regard as well. We want to do security patching, apply latest patches to our infrastructure. We also want to do pen testing occasionally. It would be amazing to have pen tests on each release, but this is just not feasible. It's not possible due to the nature of how pen testing is performed. So it can come as a problem both on performing it and justifying cost of each pen test on the each release, especially if we are doing releases multiple times per day. Now, still, we want to do pen testing, and we want to do it as often as possible. Ideally, would be that we run it once per sprint or once per week, but a lot of organizations are satisfied with running pen tests once per quarter or every 6 months. So that is something to keep in mind as well. We need summary reviews of critical tasks. We need to keep track of what's going on, what are our highest priorities, what are our security results, what we need to address immediately, the level of security risks that some issues may possess, and based on that we need to prioritize and decide what needs to be done when. We want to do assurance scan just so we can sleep better at night. We want to do occasional sweep just to verify that everything is good. We want to keep track of role-based access activity. We want to maintain that good situation where we have all necessary permission and no one has access to certain things that shouldn't have access. We also want to do security metrics, trends, and activity to keep track of everything going on across the environments. And we definitely want to do runbooks for auto healing. We want to have automated response in certain situations. For example, if an application is under denial of service attack, we might want to do a response to blacklist certain IP addresses so our application can still run smoothly. Or if we are under some kind of attack, for example, if someone is doing brute force on the infrastructure, we might want to do the same thing and block those accesses from our infrastructure, blacklist those IP addresses, and prevent them from gaining access to our infrastructure. There are some other things that we also need to keep in mind. We need to keep track of access management, who has access to what, when, why, what kind of access. Use just-in-time and approach and just-enough administration approach. I'm a big fan of those, both in DevOps and any other security way, because just-in-time access provides you with the access only for a limited time when you actually need to do something. Just enough administration approach gives minimum needed permissions that will help you do your job, but that don't give you too much permission. So even if due circumstances someone's account is compromised, we are trying to keep damage minimum to our environment. Basically, those approaches are giving you also an option to review when someone was actually using certain access, or are they using it long term or not using it at all. There are many times, especially in the operations, people have too much permissions and they have their permissions activated at all times. With just-in-time and just enough administration approach, we're keeping this at minimum, because even any kind of elevated access needs to be pre-activated for a certain amount of time, and then we can review if someone was actually using it recently or not. So if we have people that have certain admin permissions to do certain things and they didn't use it for over a year, they probably don't need it anymore. So we can review access settings and keep them up to date. We also need to keep in mind data security on how things are gonna be set up around our in our environments. Is data encrypted at all times? Is it encrypted at rest? Is it encrypted in transit? How we are maintaining that data? What's happening to the backups? How the data is accessed? Who has the access, and so on. We definitely want to do network security scannings. We want to keep in mind what's going on in our network across entire network, because usually we keep in mind just a single application, but threats can come from certain actors inside our own network, from the angry employee or someone who gained different resources in our environment, and so on. And also something that we need to keep in mind is physical security. Now that part is kind of forgotten with the cloud computing, because cloud providers are taking care of physical security for our infrastructure, and we don't need to think about it. Basically, they are providing top of the notch, something that most of the organization could never do on their own. But a lot of organizations are still running in local data centers, in local environments. So physical security is something that we need to address. Like, if we have a server room, if we are keeping infrastructure on-prem, we need to see how that infrastructure is accessed, who has the access to those rooms, who can access the hardware, who can access the operating systems, and so on. We need to keep that in mind as well. Okay, finally, thanks to our sponsors today. This wouldn't be possible without them. Also, thanks to all communities supporting each other. These last few months has been difficult for all of us, but I really enjoy how all the community comes together. The number of virtual events is kind of amazing, and it's providing people to access to all sorts of information, to knowledge, and it has been really cool. I really enjoy supporting community conferences, and they are my favorite to speak at, definitely. Before we end, also keep in mind that we have many great sessions today. Right behind me is Kanika. She's gonna do a great session on GitHub Actions. It's really cool, something new, something cool, so go check it out. Thank you for your time today, and I hope you enjoyed my session.